Hello. 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 Good afternoon. We have uploaded marking for lab 2 as well. So you may need to have a check by, I reckon it's Wednesday. Maybe we will release on Tuesday. And you can have a check of the outcome. It's pretty good, but like some student may have some issue on their programming part. So make sure you check your outcome so you don't have this like similar mistake in your next report. And we still have a few people that didn't come, but Let's do a small test at first and see how it goes. Give me a sec. Okay, can you see my screen? And okay, try to answer it in the chat. Is it true or false? Yeah, I see the correct answer in the chat. It's false. So in this question, we need to figure out what is the difference between circuit switching and packet switching, and we will have a look of it later. Give me a sec. This one is very important. Try to calculate. I'll give you 3 to 5 minutes. You can have a look of the slide and then do the calculation. Any idea? Okay, so we have different answers. Uh, this one is the real question in the midterm exam in past years. But in this year, we will have like similar one, but not this one. Then you can like have a screenshot and save it and try to calculate this one later. And we can have a look at it later because we need to go through the slides to understand how. Sorry, it seems like disconnected. Let me show you one more question. Don't worry about the answer about the previous one. We will go through the calculation later when we cover that part. Yeah, have a look of this one. Sorry, it seems I disconnected again. I use my mobile network to connect it, right? Please let me know if you can't hear me. So this question is also a real question from midterm exam, and you may have like you may met this kind of question, this kind of graph in your midterm exam. So it would be very helpful for you to understand it beforehand. And you may find it quite similar because we have this one in our slides. So try to answer this question. Yeah, this question is not really hard, and you can just try to answer me true or false in the chat. We are not going through the details of it. Is it true or false? Yes. Can you hear me right now? So what is the answer for this one? This question, true or false? Is this selective repeat? Okay, in order to save time, the answer is yes. And you need to figure out how could this happen. And don't worry, we will cover this part later. And let's have a quick look of this. You can find this PDF file in the midterm exam information. So in this semester, we have extra 5 minutes to do it. I think they upload a wrong one. Let me try to find a new one. Give me a sec. Okay, so this is the correct one. 75 minutes. And this is Sydney time. So if you are in different country, then you need to be aware of this. for the midterm exam, this one is very important. So don't be late, otherwise you will lose your time. And as you can see, I have already shown you 3 different questions in the midterm exam, and we have around 15 questions in the exam. So you don't have much time to check the slides and do the calculation. The time is really limited, and you need to be really quick on answering these kind of questions because it's really confusing and you may spend like 10 minutes for each question. And the first thing you want to do is to downloading all the slides and merge them into one. So you can just search the keywords and then just quickly find the answers. Let me show you how to do this. So as you can see here, I download all the slides and then merge them into one. So if I have any question regarding to the, let's say, selective repeat, then I can quickly find the answers by search this kind of keyword. Then I just quickly find the lecture slides and have a look, then try to answer it. So this one is really helpful, and I have already done it. So and I can share it with you in the GitHub link. I will upload this kind of stuff into the link later. So the first thing you want to do is to merge all the slides into one, so you can save the time by do the keyword search. And the second one, you don't need to worry too much about the content we cover this week, because we only care about the content from week 1 to week 5, and there's no congestion control. If you have any question, like for the midterm exam, like any general question. And we have a mock test at this time. If you didn't go through the contents in here, especially for the video, then you may need to have a check. Oh, they didn't show it. Maybe I can show you, upload it to my GitHub link. So, since we don't have a midterm exam video this semester, and here's some useful information from last year, then you may find it useful. So for the midterm exam, here are some statistics. As you can see, the average is pretty bad, 10.4 over 20. So it will not be very easy to get high marks. But don't worry, let's see how to do the preparation to achieve this area. So the first thing you want to do is to go to the lecture and like go through the content one by one. Don't need to go through the course introduction, but you need to have a look of this kind of slides. Then you will see we have a lot of quiz inside of the lecture slides. This kind of quiz, and try to answer all the quiz and comparing with the correct answer. So you can't see the answer in the slides, right? Then you need to go through the recording of the lecture to find if you get the right answer. This is very important. As you can see, we have quite similar question in the midterm exam. For example, this one, the switching one. They are basically the same meaning, but in different kind of question. So you need to go through all the quiz in the slides in order to like understand all the contents here. And that's the first thing you want to do, go through all the quiz. And the second one, we have prepared some like mock test material so you can have a look. I think we will release some sample midterm exam question. Like this. I can show you right now. And if you want, you can take some screenshots. Like this is the question. Let me put it into the okay. So this is also a real question from the midterm exam. So you can like take a screenshot, or I will upload it into our GitHub link so you can have a check. But we are not going through them because like we have too much questions. In here, I will just show you how to do the preparations. And we have a tutorial content for today, which is this one. We have this kind of question, but as you can see here, it's not quite similar as our midterm exam, but you need to go through them because it could be useful. But we already have the answer uploaded in GitHub. So I would like to leave this one to you after you review all the content in the slides. And after you do all the quizzes, then you come to here, try to answer these questions and compare with the correct answer. Then you will figure out like which part you are not familiar with. Then you need to spend more time on that part. Is that okay? And the rest of time, I would like to go through all the content in the lecture slides with you. And I have prepared some material to be uploaded. So you will find it in the GitHub link. Include the answers of the tutorial 1 and the merge file, and the knowledge point could be useful. Let me try to open it. Seems to have some problem here. Okay. So here's some like knowledge points. You can go through the content by yourself. Give me a sec. Let me open my slides. Okay, today we are trying to like cover all the content we have learned, and I will try to mention like which part is very important according to our slides. And let's get started. So we have 2 chapters. First one is the networking. The second one is the application layer. Third one is UDP and TCP. I have specified the page number in here. This one, you can try to find it in the merge stuff. Where is my merge slides? It's in here. So I merged the slides and specify the page number. For example, the page 34. Then you need to go to here, circuit switching. And I also have some annotation in the title if I think this page is very important. You can see I highlighted this page, then you can spend more time on this page. Okay. Then we go to next one. Give me a sec. So the first thing is you need to figure out what is the difference between the packet switching and circuit switching, and try to answer the question. The question is from the slides. I just simply copied from the slides, and let's try this one. This is the difference. Can you try to answer this one? A or B? So if we have a lot of wrong questions, then we will have a check of the slides in details. Any idea what is the difference between packet switching and circuit switching? You can try to refer to your slides. Let's wait for 1 minute. And this is the most important question for this chapter. Okay, so it seems it's a little bit confused, right? Some 50-50, both on A and B. And we can try to come back to the slides and try to figure out what is the answer. It's page 34. And 40. Thank you. So for the circuit switching, every computer will have its allocated bandwidth and did not share with other people, which means you will have fixed upload or download speed limits, and it will not be used by other users. If you are sharing your network with other people, then you will figure out like sometimes they are downloading a movie or a huge video game, and your internet is very laggy because they are using the internet, especially for uploading. So that's circuit switching. But now, if you are using a circuit switching network, then you will have your own connection between your computer and to the server. So your internet speed will not be affected by other connection, like in the same room. So you can see the important point is not sharing. And for the circuit packet switching, we will like divide the packets, divide this kind of images, the data we want to transfer into different packets, and transfer the packets one by one. So, and we are also sharing the connection. Let me try to find the, yeah, so it's in here. So we forward the packets, and we also share the internet connection. So what's the answer now? So you should be able to find the answer in here, no sharing. The answer is A, right? And you can go back to the first page and have a check. The circuit switching is inefficient because everyone will have its own bandwidth and they did not share with other people. But the packet switching, which is the internet we are using right now, will share the bandwidth with other people. Yeah, so this is the difference. If you get the wrong answer, then you need to have a check of this part. Let's go to another question about delay. So usually we will have a calculation in here regarding to the delays. There are four kinds of delays: propagation, processing, queuing, and transmission delay. Then the first thing you want to know is which one is the processing delay. So in these images, which one is the processing delay? It's in here. Let me try to draw. So we will have a processing delay at this point. When we have a packet arrive from our computer, which is A, to the routers, then the first thing is the router need to read your packet and then understand how to forward your packets to another router or to the destination. So the first thing is to have a processing delay. And the second one is the queuing delay, which is in here. So if the router is very busy, like for example, we have a lot of connection, including A and B and C and etc. You have a lot of computer trying to send packet to the outside via this router. Then we may have lots of packets inside the routers. So we will have the queuing delay. And the transmission delay, which means when the routers are trying to send the packets from the router inside to the outside of the router to the internet, it may take some times. And I have a question here. For example, you have a 100 Mbps. Can you see the Mbps bandwidth? Then you have a like 1 gigabytes. So this is one of the question in the midterm exam. Can you try to answer this one? So we are only calculate the transmission delay here. So what is the answer? Now we are trying to send a file, which is 1 gigabyte with the like 100 Mbps bandwidth. And how long it will take? Can you try to answer this one? Because it's a real question, but it's a simplified question in the midterm exam. The real question is harder than this one. If you can't answer this one in like 1 minute, then you may have trouble in the midterm exam. Okay, let's try to calculate this one. So we have 1 GB. So we all know time equals to the size divided by speed, right? So all we need to do is to align the units of the size and the speed. So 1 GB is equal to how much? Equal to 1024 MB, right? And divide by, is it 100 or other number? Divided by 100 Mbps times 8. Do you know why do we need to times 8? This is because, yes, the bytes to bits conversion, 1 byte equal to 8 bits. So you can see this is the key point on the transmission delay calculation. And now you get the answers. And I would say, like, for this kind of calculation, 50% of people cannot get the correct answer. So you may need to pay more attention on this part. So the first thing you want to know is about the conversion from byte to bits. And the second one is the conversion from the size, 1 GB equal to how much, like, megabytes. So this is the transmission delay calculation, and we will have a, what is this? Propagation delay here. Propagation delay. Do you have any idea how to do the calculation for propagation? Let's try another calculation here. So from the server, from the router to our server, router A to server and equal to, let's say, 3,000 kilometers. And the propagation equal to how much? And usually in the question, we will mention this speed of light equal to 3 times 10 to the power of 8. Yeah. Yeah, pretty close to the correct answer. So this one is pretty easy to calculate, right? The propagation delay will equal to the physical distance divided by speed of light. Yeah, so in the question, we usually mention, like, what is the speed of light? And we may have different answers here. And I would say your answer is correct according to the lecture slides. And in the, like, midterm exam, usually for the easier calculation, we will give you the speed of light in another number so you can easily get the answer. So that's the calculation for propagation delay. So now you know how to calculate the transmission delay and propagation delay, then you will be able to answer this kind of question. The processing delay and the queuing delay is always given in the question. So you don't need to worry too much about this part. It should be a fixed number. And here the question, sorry for the Chinese here. What is the propagation delay? Does it depend on the size of the packet? Yeah, the answer is false. We only care about the physical distance of it. And then this one is too easy for you, so may not be tested. Try another one. Try this, the first one here. So we are on a circuit switch network. And what is the answer for this one? For each user, they will use 1 Mbps. Yeah, because this one is a circuit switch network, so they are not sharing the bandwidth. So we don't care about the probabilities they use. We only care about how many people do we have. We have 100 users, and for each of them need 1 Mbps. So it's 100 times 1 equal to 100 Mbps. So the answer is A. And we come to another question. All the parameters is the same, but we use the packet switch networks. So what's the answer right now? Yeah, so I see you have the correct answer. It's pretty easy, just 100 users times the bandwidth they need, which is 100 Mbps, and times the probability of the usage, and we get 20. Next one. This one is about the queuing delay. So what's the answer for this one? We are asking like if the queuing delay depends on the physical distance of the connection. So the answer is no. The physical distance, the physical length only affect the propagation delay. And the queuing delay will be affected by the traffic of the connection. Like if we have a lot of computer connected to router 1, then the queuing delay may increase. Okay, so that's all the thing you need to know in the networking. And now we come to the application layer, which is harder. We have lots of things to be covered. So the first one is about the layering. You need to know how much layer do we have. And that's the main content we will learn in the course. We will have 5 different layers. We have already learned the application layer, and we are doing the transport layer, and we will learn networking and link layer in the future. Don't worry about this one, too easy. Okay, so this one is the difference between TCP and UDP. What is the answer for this part? Yes, you are correct. TCP provides reliability, but the UDP does not. So that's the main difference between them. But in the midterm exam, we will not have this kind of question. It's too easy for you. Instead, we will have some question regarding to the HTTP. So for the HTTP, maybe we start from the status code. So what is the status code for HTTP? Let me show you the slides. So we go to the status code. As you can see here, we have a status code in the response, and we will usually have this kind of question in your midterm exam about the status code, because the HTTP, we don't have much thing to be tested. So the status code, it will be very likely to be tested. So all you need to do is to go through this page, know what kind of status code do we have, and what is the meaning of that. For example, if we have a status code starting by 2, which always represent kind of succeed, like request success or this kind of meaning. And if we have a status code starting by 3, then it will means we will like have a redirection in this kind of status code. And if we have a status code starting by 4, this represent which kind of error? Is it the server side or client side error? Okay, so the 400, so 400, that request, which means we have a wrong request, right? So it's from the client side error, and the 404 not found, which means we requested a document not found on this server. So it's not server's fault, it's client's fault, because we are asking a file that does not exist. So as now you can know, if we have any status code like starting by 4, which means the client side have some error on making the request. And the same idea, 505 or 5XX, 502 or something, will be the server side error. So you can get some idea of how the status code works. And what's next? Let me check. What else do we need to know? Yeah, next one is the method in here. As you can see here, we have lots of methods in request. Then you need to figure out like, why do we need to use this kind of method, and in which case we will need which kind of method. For example, the post and the get, what is the difference between them? And if I want to log into Google server, which method are we using? Yeah, that's correct. We usually use post method to upload the content into the server. So that, which means we usually use the login function with the post method. And the same idea with the put, delete. For the put, we usually use it to like update some records in the server, and delete, obviously we use it to delete something. And that's it. What's next? The HTTP version 1.0 and 1.1. That's the main stuff. We need to find 1.1. Yeah, so it's in here. The next thing you need to know is about the difference between the 1.0 and 1.1. The main difference between them is the persistent. If you have a look in here, persistent is like in 1.0 is like this one. So for every connection, for every transmission, we need to establish the TCP connection every time. But with the persistent connection, we don't need to establish TCP connection every time. Does that make sense? Like if you like still have no idea how this works, please let me know so I can have more details about this part. But in the persistent HTTP, we only need to have one TCP establishment, and then we can send lots of file in this TCP connection. And another thing about it is the pipelining. As you can see in this graph, the pipelining, which means we can send 3 different requests at the same time, and then we can get a response very quick instead of sending the request one by one. So we can save time. So now we can come back to the slides and try to answer the questions here. Try to answer this one. This one is one of the quiz question, but it's a bit hard to be understood. So try to answer this one. Okay, so we got an answer right now. Then we try to figure this out together. So we need to draw two lines to simulate how this connection established. So we will have a client side here, left hand side, and we'll have a server side, the right hand side. And we will try to figure out how they communicate with each other with the persistent HTTP connection. So the first thing we need to do is to establish the TCP connection, right? So which is the sing and ACK. And the next step is to get a file, request, and response. And here is to get a file, HTML file. As you can see here, we have HTML page, then we have an inline objects inside the HTML. So you can imagine we have lots of images inside the HTML file. So we need to get the HTML file first, and then we can request other images inside the file. So next step is to get images inline objects. So in order to get the objects, what do we need to do? Is this simply is this just simply a request and response? Is it? Or do we need to establish the TCP first? Because we are using the non-persistent connection. So we need to do the TCP connection again, and then we can send a request to get the images. So that's how we get the files. And because we have n objects, which means we need to times n at this part. So this part need to times n because we have n objects. So now we can do the calculation. For the first part, we have established the TCP connection, which is the value d, the RTT equal to d, right? And in here, we also have a d here. And this one will equal to the, what's the value of this? We will have a d plus the file size, which is the s, s0 divided by the bandwidth divided by the capacity, which is c. And in here we will have d plus s divided by c, right? So now you will get the equation will be d plus s0 divided by c plus m times d plus s divided by c. Then you will figure out the answer. So that's how we do the calculation for this kind of question. And this could be tested in the midterm exam just to test if you can understand what is persistent and what is non-persistent and what is the pipelining. Then we come to the next one. This time we have persistent HTTP. So what's the difference in here? So with this one, because we are using the persistent connection. So we don't need to have TCP establishment anymore. We only need is just one establishment for TCP connection. And then we can send all the files and request. So what's the answer for this one? Is it E? Yes, it could be correct. So we can do the equation again. B plus D plus S0 divided by C, and plus N times D plus S divided by C. So that's the answer. And that's how persistent HTTP work. And finally, we come to the last question. This one. This time we are using persistent HTTP with pipelining. So what is the pipelining here? As we mentioned before, the pipelining allows us to send lots of requests at the same time, right? So we can just simply change this part because we still need to get the HTML file at first. Otherwise, we will not know how many files inside the HTML file. So the first part will remain the same, but the second part will be slightly different. We will send a lot of requests at the same time about the inline objects. Then we will get a lot of response to here. So inline objects. And what's the value for that? It will be equal to D plus inline objects, right? So M times S0 divided by C. So the answer for this part will be slightly different. So it's D plus S0 divided by C plus D plus N times S0 divided by C. So that's how we do the calculation in this part for the HTTP. So if you are still confusing, try to do the calculation and draw this map by yourself. You need to draw this one by yourself if you still have no idea what is going on, and you will figure this out. So that's the calculation for HTTP. And next part is DNS. For the DNS, usually we don't have much calculation, but we may have some short answer question for DNS. So you need to try to understand how this works, and you need to also know how the hierarchy for DNS. And actually, I don't have much thing to say because there's no calculation. All you need to do is just go through all these questions by yourself and try to figure out which part you are not familiar with. Then just have a look. This should not be a problem. And try to answer this one. Is it A, B, C, D? Which one? And for this one, we can also try to draw something to see how it goes. How does this work? For example, we have 4 routers, 3 routers. This is our PC, R1, R2. No, it's DNS server. I'm sorry. So this one is your local DNS and DNS2. This one is it. Authoritative DNS. So in this case, if we have no idea what is the IP address of a website, if we want to connect it to another website, then we need to ask, like, what is the IP address of the website, the IP address of website. Then we will firstly submit the request to our local DNS. And if our local DNS does not know this one, it will go to the another DNS, like root DNS, and we will finally reach the authoritative DNS, which have the records, and it will come back. So the maximum number, we will not know how much is that, because in the middle side, it could be a lot of DNS. So in this part, we may have 1 or 2 or 3 or whatever the number is. We may go through a lot of DNS. But what is the the minimum number for this? So you need to consider in this case, in here, someone choose 2 because I draw this graph, but the answer is not 2 or 3. Okay, I just want to let you know how the DNS works. So in the middle side, we may have we may have lots of DNS server. We will go through the root DNS and the .au DNS, and we may go to the edu.au DNS and etc. We don't know how much DNS server inside in the middle side, but we are asking about the minimum number of the DNS server. So we don't care about how much in the middle side, because in the best case, for example, we have another computer here. We have like Tom's PC. So we have a PC in here. Then the Tom PC may requested the same website before. So we have a cache in the local DNS. And the local DNS already have the answer for this, which means it can directly answer our question. So what is the answer now? So just imagine this. Tom already visited this website before. So the local DNS already have the records for the IP address inside. Like the local DNS will have a table like IP address and URL, and you will say 1.1.1.1, which is the settings.com. So you can see this table is already inside the local DNS. So when we reach the local DNS, it can directly give us the answer, which is 0 hops, right? So this one is the answer. Yes. So this question is quite tricky, but we just want you to know how the DNS works. As you can see, like the hierarchy request from the DNS server and how the cage works in DNS. So if you get the wrong answer and if you're still confused about this part, just go through the slides and it will be very helpful. Okay, so next part is the P2P. P2P, we usually test this part, the tit for tat. Do you have any idea what is T for tat? Like T for tat, I don't know, we don't have any question here. Yeah, it's this one. So I will maybe just simply ask you to answer this question, just yes or no. If we get a lot of wrong answer, then we have a look of the slides. Is it possible? Just give me an answer. Or have no idea? If we have no idea, then we need to go back to the slides. So we have a look of the tit for tat at first, then we answer the question. So so firstly, we need to know like what is P2P? P2P is just basically every client is a server, so they are sharing the file with each other. This is very popular for the like free movies and free books. So we usually use this kind of thing to share the content, which is not allowed legally. And let's have a look. What is the strategy of the P2P protocol? So how they share the file, you can see. We usually share the file with the peer who share the file with us with the highest rate. And for every 30 seconds, and we randomly select another peer and share the file. So why do we need this? Instead of, besides sending the file to the highest rate peers, why should we have this strategy? This is because if you are using a very low speed internet, then you will never get file shared without this protocol, right? If I'm using a very slow, silly speed, then I may not receive any content from others. Otherwise, I still can receive the content if I have this one. So every 30 seconds, they can share the file to a random person. So I may be the lucky boy. Then I can receive the file. So we can come back to the slides and try to answer this question right now. So is it possible? If I share nothing, if Todd don't want to share nothing, don't want to share anything, is it possible for him to get a whole file? The answer is yes, right? Because every 30 seconds, we will share the content. Next one, CDN. I don't think we will test a lot of things about CDN, but you need to go through the slides of what is CDN, and like how can we use it. Any idea for the CDN? Like, give me a brand of CDN, or how could we use it? Like, name an application who use the CDN. This is one of the questions in the midterm exam. So yes, I saw the answer here. Netflix. Yeah, exactly. So we usually use the CDN with the YouTube or Netflix, or even some web page which have very high volume. So if you visit their website, then you can see they may use different IP address, and that's the reason, because they are using different CDN, which means you can connect to the server without connecting to the overseas server. Just connect it to the local server and you will get faster speed. And that's how CDN works. Let me draw something to help you to understand it. So for example, you have your own PC and we have YouTube, because YouTube is like, the server is in America, but we are in AU. So how can we connect it to YouTube with very fast speed? So that comes to the, for example, we use the Cloudflare CDN. Then the YouTube will share the content with the Cloudflare CDN. You can imagine they save a lot of video files in the server CDN server, and the Cloudflare can just simply connect it to us with very low delay, like 1 milliseconds. And here it could be 100 milliseconds. And if you go through from the YouTube to your computer, it could be, let's say, 300 ms. So when you use the YouTube, we will only feel, oh, this is so fast, because the video content is already in the CDN server. So you will feel, oh, only 1 millisecond to reach the video content. So that's how the CDN works. And we don't need to have this part. So you will not feel the 100 milliseconds here, because the content is already in the CDN server. And if we don't have the content in the CDN server, then we will go through this path and you will have extra delay on this part. So just go through the slides and then you will understand how CDN works. And CDN is optional in the midterm exam, could be tested and may not be tested. It really depends. And for the reliable data transfer, it's about the transport layer. So we come to the transport layer right now. Then the thing will be tested is about the version of it. So go through the slides and know what is the difference between the versions. The question will always related to the versions. So it will ask you like, what if we are using the version 2.2 to send the file, to send the packets? And what if we are using the version 1.0 to send the packets? So you need to know exactly what is the difference between different versions. And the next part is the go back and selective repeat. Maybe we just have a look of the lecture slides and make it easy. Where is go back and here. Okay, so here is go back and pipeline protocols. So just imagine we have lots of packets to be sent it. So what can we do with this kind of protocol? And what if we have packet loss in the middle side? Let me find the slides in here. Yeah, so this one is usually tested in the midterm exam. Go back in. So what is the protocol? So firstly, you need to understand what is the graph in here. So in the green color is the packet we have already sent to the server side and it's already acts, which means they have already received the packets. And the yellow side, yellow stuff is about the packet we have already sent it, but we didn't receive the acknowledgement. And the blue one is not yet sent, right? And the white one is not usable, which means because we only have the Windows side here, and we are not allowed to send lots of packet at the same time to avoid the traffic congestion. So make sure you can understand this graph because this graph is very important for go back and selective repeat. We always test this kind of stuff with this kind of graph. And let's try to do this one. I have a question for you right now. Okay, this one. Example question. This one is also a real question in the midterm exam. So try to answer this one. So with this image, is it go back and or selective repeat? And you need to know what is the color mean. and try to answer this one within 2 minutes. Because in the real midterm exam, we don't have much time to answer this kind of question. And this one is the easiest one in this part. You can go to the slides and just have a quick look and then try to answer this one. Okay, so most of us get the correct answer. The answer is A. It could be go back and or selective repeat. And let's try to figure out what is the difference between them. So this is go back and. Go back and which means if we have a packet loss, then we will go back to the beginning and send them all. Let me see if I can find, yes, this is the graph. So we have a packet loss in here, the packet 2. So what if the packet 3 already arrived and acknowledged, but what if we didn't have the packet 2 acknowledgement? Then we will resend all the packets, including the packet loss. Like if we already get the acknowledgement for packet 3, but it will still be resent, right? Because in the server side, it will discard. We will not save it in the cache or save it in another anywhere else. We will just drop it. And that's the reason why we need to send them all. So you can see this protocol is pretty simple and easy. And we come to the selective repeat, which means for every packet, we will have a independent packet, and the packet in the right hand side, which is the receiver, will save it into the buffer. So we only need to resend the packet loss. As you can see here, the packet 2 is lost, then we resend it, and we don't need to resend the packet 3 or 4 or 5. So that's the difference between selective repeat and go back and. So we couldn't say the selective repeat is better than go back and, because in some case, for example, the receiver may have a lot of packets in the buffer. It may buffer overflow and cause more problem. So it really depends which algorithm is better in pipelining. But all you need to know is the selective repeat is smarter because it have a timer for each packet, but it will consume more power in here. So that's the selective repeat and go back and. And let's try to have more questions in here. So we don't have congestion control, right? So we can try this one. This one must be tested in the midterm exam, but the digits in here may different. So have any idea what is A? So I can make sure this kind of question will be tested. So A equal to any idea? This kind of calculation, you need to answer this one like in 1 minute. And B equal to So let's just focus on A. Any idea how to do the calculation? This should be very easy. So give me an answer. What is it 35 or 36 or 37? Okay, this one is pretty easy, but it's just equal to the 35 plus 1. So let's say why should we use 35 here? So we have 35 in here, and we will also, because it's the same, so we need to calculate, add these two together. So that's the answer for the A. And how about B? The acknowledgement. So in here, B will equal to which one? We just look at the sequence number for the previous one, which is the 70. So it's 70 plus 1 equal to 71, right? So in the next one, how about C? C equal to this one. We are looking at the sequence number A, which is the 36. So it's 36 plus what kind of stuff? Plus the data size, which is the 50. So it's 86. And we don't need to add the acknowledgement here. And the C and the D here will equal to the sequence number B plus the data size, which is 100. And then it will be 171, right? And the E here will equal to the sequence number C and plus the number of the data. And we can see there's no data in here, right? Because this one is a thing. Then we need to add a thing here. So it will be 87. And the same idea for f. So in here, f will equal to the sequence number d plus the thing will, so you get the answer. So as you can see here, we don't care about the egg, but we care about the thing and thing. Is that okay? So this one is very easy to get a wrong answer, because usually we will look at the egg. So we put the egg in here to confuse you. So don't look at the egg. We don't care about the egg on the calculation of the sequence number. We only care about the thing and the thing. So please remember this if you have this kind of calculation in the midterm exam. Okay, so I think that's it for today. We go through lots of real questions in the midterm exam, and should be enough for you to do the preparation. So now you have some idea like which part you are not familiar with, then you can spend more time on the slides and the recordings. And later I will share the file included in this tutorial. And I hope you have a good luck with your midterm exam. And we still have a few minutes. If you have any question, just let me know. And we will have some assignment help session from week 5 to week 9. So if you have no idea how to do the assignment, you can come and have a look how to do the assignment in the help session. Oh, okay. I forgot to check some question. Okay, so the check some. This one is the UDP checksum. So all you need to do is to add the number together, and then to verify if it's just like this, all the numbers should be 1. And this is how do we do the calculation. So you just have the calculation like this. You list these two numbers and then add them together. And if you have a number exceeded 16 bits, then you move to the end of it, and then you will get the sum. As you can see here, we add 1 at the end, so it will be 100 instead of 011. And then we compare with the checksum. Just add them these two together, and then you can get the answer. So we come back to here. Oh, sorry, I delete the question, but now you get the idea of the calculation of the checksum. You can verify that one. Yeah, sorry, I deleted that question, so we can go through, but now you get the idea. We have two stuff and we add them together, and usually we will have this wraparound situation in the calculation. Then you need to move this number to the end, which means just add 1. Then you get the number of the sum. And then you can just verify with the checksum. You can just add them together, and the end of it, you should get every digit should be 1, should be in 1, right? So you get 16 1 in the final. So actually the question is in here. I remember it's one of the quiz. It's one of the quiz for the checksum. So you just go through all the quiz, then you will be able to do this kind of calculation in the midterm exam. Yeah. Feel free to ask me any question about the midterm exam. And yeah, that's it for today. Thanks for your coming, and we'll see you in week 7. By the way, we will have some help session on the assignment. We'll get started by Wednesday this week. So if you have time, just come and have a look. It will be very helpful for your kick started for the assignment. And we will teach you how to design the assignment, how to design the program, what is the protocol, and etc. No, it will be online session. And it will be recorded. And we will share the recording on the link. I think we will announce the schedule very soon. Yeah, it should be announced in this week. Maybe today, maybe tomorrow or Wednesday. Then I will upload all the midterm exam preparation material into the GitHub link. So just have a check of the link later. Yeah, and I wish you have a good luck. And feel free to ask me any question via email, but not recommended in the email because I don't check it every hour. But if you have any question, you can post it on the forum. We are looking at the forum 22 and 7. For the lab 3, we only submit one PDF and one Python file, right? Yeah. Okay, all good. Bye.